Hi, this is Gaurav. Welcome to my presentation about Lean Six Sigma on safety in construction projects. I work for DTZ under the leadership of Tibin Moza, Director of Project Management Services in India. Let's get right to it. This project's target is to define our current safety performance and propose solution to improve it. This project has a standard Six Sigma structure of define, measure, analyze, improve, and control. The important outputs of design phase are mapping the current progress and arriving on CTQs, the critical to quality components. The emphasis of deliverables of measure phase is to record data of current processes to benchmark our current capabilities. The analyze phase targets to identify root causes of issues and locate the wastes in the process. The improve phase forces our thought process to provide best solutions for leaping into the next level. The control phase pilots a project to record results and will come in action upon approval from senior stakeholders. Let's move to the define phase and have a look on the project charter. As per our director's statement, our team is given the task to measure safety process inefficiencies, identify causes, and propose solutions. The business case exists as despite the presence of existing policies and dedication to implement, a fatality has happened and concerns are still noted. In the initial kickoff presentation, we have briefed about the objectives and expectations from our project. Let's move to the Kano analysis, using which we have prioritized the must-be's and primary satisfiers. Reducing fatalities, near misses, and minor injuries tops our list. Also, reducing non-compliances, improving safety process, and reporting falls within the high importance range. Let's arrive to key process output variables, which are derived from our voice of business. The driving factors that have high importance are listed here. Currently, our CTQs translate into the following as per the table. Fatalities to be reduced to 0. Number of near misses to be reduced to 15. Number of minor injuries to be reduced to 4. Number of safety non-compliances to be reduced to 30, all above measured over a quarter of construction in a single project. Let's go ahead and look at the value stream map. Currently, our process flow is as per the diagram. Thus, we have safety audit to deliver the safe work that takes 54 hours as a process. Our estimate of value added time is 9 hours in this process. Moving ahead, we take a look on cause and effect matrix. The following type of common causes are derived upon brainstorming post the site observations. Use of hazardous substances, use of combustible materials, trash on sites, things like missing personal protective equipment, lack of training, long process flow, and less inspections form these groups. Cause and effect matrix. Speaking of data to provide reasonable importance number to various causes, we have this matrix of cause and effect. Thus we arrive on perceived importance of level for the following groups. PPE group, which is the personal protective equipment group, lack of training group, management philosophy group, contracts, inspection group, work at heights, trash, visual group, storage, and hazard group. Let's move to the next phase, which is measurement phase. We have put a measurement plan in place that defines who measures what part of the input causes and output effects. The plan has measurement frequency and defined way to record each entry. The resultant is our record sheet of Y's and X's. Note that Y's are outputs and X's are inputs. Any Y, the dependent output, is a function of X, the input variable. Capability check. The process capability check allows us to find the short and long-term repeatability of our processes. In the first graph, we have identified the outlier in the near misses using interquartile range and corrected this value so that capability check can be performed. The positive values of PP and CP show how repeatable our process is and can it be performed to the current levels again. More positive the values, higher are the confidence level of the repeatability of our current processes, with similar results. The defect per million opportunities and the sigma levels. Calculating our sigma levels, we realize that our performance is fair in lost time injury rate and minor injuries. However, we are not so good at near misses and non-compliances. This calculation forms our benchmark for future references and marks the point of improvement. The next phase is our analyze phase. Our first task is to locate the root cause of the deviations. We are taking up 5 why analysis to arrive on qualitative conclusions. I'll take an example from here, the lack of training group X2. Why does this exist? No professional training programs from contractor side. We ask the question again, why? Need not recognized. Similarly, customers' general acceptance standards. Focus on physical and time deliverables. And ultimately, it results into the conclusion that PMC is not setting up stringent ground rules like asking for safety training certificates. Our next slide takes us into the statistical analysis of our data where every output is analyzed. We notice that our processes are outside the control limits, have low confidence on long-term stability and repeatability. We notice that the normality test p-value is less than 0.005 for minor injuries. That implies the process data faults or abnormality in the process. Let's move to the KPIV scoring, which is the team scoring for all input variables. The purpose is to identify the prioritized values of all KPIVs. We observe that the inspection group tops the rating and is joined by working at heights and PPE. Next slide shows a visual representation of the scoring. Let's move to the identification of wastes in the process. A waste is defined as something that doesn't add any value to the service for the customer. We observe that there are only 2 steps that add real value for the client or delivering safe work. These 2 steps are audit and manual implementation of audit. Rest of the items are encircled and non-value added. Leaping into the improve phase, we have shown the ideal process map here. It has 2 steps resulting into the ultimate output. The important facts are that this process has only 12 hours of lead time compared to our 54 hours as per our existing process. The value added time is reduced to 6 hours instead of 9. Thus value added time stands at 50% of the total time spent for this ideal process. In our next step, we have selected the 5 most important KPIV groups out of the list of the 10 groups. And these groups are the inspection group with the root cause, lack of planning and timely action on construction plan. Next is work at heights, mandating IRATA certified manpower for scaffold is absent in contracts. Next is the PPE group. The root cause for this group is underqualified recruitment by the contractor. Next is the hazard group. The reason is concluded as joinery manufacture not restricted to offsite only. The next is the lack of training group, and the root cause for this is analyzed as PMC not setting up stringent ground rules like asking for safety training certificates. A visual representation is shown in the next slide. Scamper. Scamper is a systematic technique that forces one to think out of the box. In the resultants, we observe that we can substitute old reports with interactive online live reports. We can combine all these steps of our process into mere 3 steps. We can adapt project management staff to help in this new method. We need to modify the service level agreements for different KPIVs. We can use this new process for project management. We can eliminate unnecessary steps. We can rearrange the process into a multi-directional process. We will shortly look into the outputs arrived from Scamper. Let's move to the FMEA that shows us the recommended actions based on if KPIV totally fails. We have assessed the severity index, probability of occurrence, and our ability to detect the risk. Our next step is to combine our conclusions from KPIV, Scamper, and root cause analysis into an action plan. So here is our action plan. We have 3 groups of readings. The first group is from KPIV, the second group is from Scamper, and the third group is from the root cause. Going ahead, we have a mistake proofing list for us. Let's take a good look into this and compare it with current procedures. For improving safety, we must stick to these new 7 commandments. The very first is contractor deploys safety marshals on site. The second is contractor supervisor are qualified diploma holders. Third is contractor submits training certificates for all staff. training for inspection given to marshals with checklists, committed smooth pace of construction works as per plan. Contractor provides at least one full-time IRATA certified level 1 marshal if any scaffolding work is involved. The joinery must be manufactured off-site. We have decided to run a pilot project in one of our upcoming construction sites for 1 month and record the results. Now it's time to look into our new process for safety. We are going to use iPhones or connected cameras with Facebook-like but formal platform where we have direct interaction with our client, contractors, and PM team for safety. An example of such platform is Asana. Once a violation photo is taken from the site, it is immediately uploaded with a comment onto Asana platform and a message is sent out to all the stakeholders. Thus, a set of such photos will essentially form our report. All important stakeholders, including the contractors, can immediately comment on the photo report, thus setting up a deadline. Contractor or PMC finally posts the rectified comments and close the photo. So here's the list of advantages with this process. There is no time loss in report transfer. Second, good photographic report will be derived from the application for each day. Next, PM team can support safety officers throughout the week whenever they take a round. Direct and factual display of contractors' performance. Safety officer can visit multiple sites in a day, thus saving costs and implementing better. Direct, unbiased records can be viewed by all stakeholders. As all parties can comment, the process becomes fast, dynamic, and reversible. We intend to implement this process along with the action plan on the observed results. I thank the project director Deben Moza for entrusting me to work on this project. I have received a great amount of guidance and focused approach on vision. I also thank regional project managers Mail Raj and Ranjan Biswas for active guidance, participation, and bringing the best out of me. Lots of appreciation is passed to the team members for their participation and activities in this project. Our next step is to implement what we derived, conclude, and improve continuously. I look forward to control phase authorization by senior management and implementation of the same. Thank you very much.